Now, what are the various hypothesis tests we have? Okay, based on data, suppose your data is continuous, normal and not normal. When data contains qualitative characteristics such as honesty, criminality, loyalty, opinions, preferences, then we go with these kinds of tests: chi-square test for association, test for single proportion, logistic regression and all. And your data is a continuous one and normal, then we can go with Z test, t-test, ANOVA, regression, all these tests. So based on the purpose, based on the nature of data, we select different hypothesis testings. Okay. Now I classify hypothesis testing into two categories: hypothesis testing for attributes, hypothesis testing for variable. So let me explain what exactly attribute means and what exactly variable means. So hypothesis testing for attributes. Okay, attribute in the sense qualitative characteristic, or the characteristic of any particular subject which cannot be measured with the help of numerical value. Rather, it would be identified by its possession. That is called as attribute. So attributes, synonym for attributes are qualities. So honesty, how many people are honesty? We can calculate, we can identify how many people are honesty, but we cannot calculate how much honesty a person possesses. We say that he is a highly honesty person, or he is not at all an honesty person, but we cannot explain honesty with the help of a numerical value. You cannot say. Similarly, beauty is also attribute or qualitative characteristic which can be identified by its possession, but you cannot measure with the number, with a particular number. You cannot say that a girl is 200 beauty or 300 beauty. No, rather we say that she is very much beautiful, she is not at all beautiful. So please do understand, there are some qualitative characteristics which are to be which are going to be tested, and there are some quantitative characteristics which are going to be tested. So the quantitative characteristics like height, weight, volume, pressure, all these things are comes under variables, and honesty, criminality, beauty, loyalty, opinion, preferences comes under attributes. So in a population we are going to test attributes as well as variables. Okay, so let me show you next slide. Now this is hypothesis testing for attribute, test of significance single proportion, test of significance association. So test of significance single proportion, test of significance for association of attributes. What exactly this meant for? For example, as I explained, I explained with this slide. Now if you look at this particular problem, you'll understand it. Okay. In a sample of 1000 people in Maharashtra, 540 are rice eaters and rest are wheat eaters. This you understood based on a sample survey. Now, based on this sample survey, can we assume that both rice and wheat are equally popular in this state at 1% level of significance? This is the question. That means that can I assume rice and wheat are equally popular? But what exactly the sample is stating? Out of 1000 members, 540 are rice eaters. That means that you can say that rice is more popular than wheat. That is the understanding, but that is the information explained by the sample. But how much sample you have taken? It is only 1000. Suppose if you increase the sample by another 1000, like 2000 or 3000 or 4000 or 5000, then this proportion may change, right? So that is the reason we need to have a scientific approach with which we could able to say, based on the sample information, we should have to test whether rice eaters and wheat eaters are equally popular, or rice eater is more popular than wheat eater, or wheat eating is more popular than rice eating. Okay, so this is a simple example for testing of single proportion. Now, if you look at this is a simple example for single mean. Now, if you look at this, a company claims that the average life of a certain type of electric light bulb is 1000 hours with a standard deviation of 125 hours. In order to test that, they have taken a 50 light bulbs and revealed that the average is 975, which is lesser than 1000. So can I reject the claim given by the that particular company? Now, how do you reject or how do you accept? Now, suppose you reject that, you may reject, sir. Only one sample is saying that it is 975 hours, so which is lesser than the claim. So we need to reject the claim given by the company. But the company asks, sir, how many lights you have taken, light bulbs you have taken for testing? I say that 50. Sir, please increase the sample size so that the information may vary. Who knows? When you increase the sample size to 200, definitely it would be 1000 only. So we are unsure about all these things because you have selected a sample of 50 light bulbs and you calculated the average life by subjecting them into some voltage, and you observed that 975 hours is the average life. So that is the reason the testing of hypothesis comes into picture. So we need to have a scientific approach to accept or reject the statement given by the manufacturer. So that is the reason we conduct the test of hypothesis. Okay. So I hope you understand the purpose of testing of hypothesis. It is a scientific approach to test your null hypothesis based on the sample. What are the sample size? You need to have a scientific approach. So for that we have different approaches to test the hypothesis. Anyways, now if you look at this particular data, easily you can understand. Now I have collected some information. So totally how many are there? 83 plus 790, 140, and 45 plus 68. Okay. So almost all I collected information from 253 members about two aspects. If you look at this, you'll understand. So my research is to one of the objective of my research is whether literacy is affecting the habit of cinema going or not, or is there any relationship between literacy and cinema going, habit of cinema going. So this is my objective. I hope you understand, right? Hello.
Yes, sir, we are getting.
Yeah, please. So anyways, all these things I answer using a Excel sheet and SPSS. I am going to show you that, but before that I am giving you some information regarding this. Now if you look at this, what exactly you understand? Being literate, the cinema goers are 83. Being literate, non-cinema goers are 57. Being illiterate, cinema goers are 45. Being illiterate, non-cinema goers are 68. If you look at these figures, you say that the people who are literates going more for cinema, right? So
yes, sir. It is an impression that we get. First impression that we get.
First impression that we get from this data is, literacy and cinema going are they are going hand in hand. There is a fair amount of relation, right? But how far it is true, we need to test it, because how much sample we have taken? Almost only 253. When you add all these frequencies, comes around 253. So, but in the population, there will be so many literate people are there, illiterate people are there, cinema goers are there, non-cinema goers are there. So, how can you say that based on the 253 people's information, how can you say that literacy and cinema going both are gelling each other, right? So we need to test whether literacy really influencing the cinema going or not. Okay, so these are some aspects where we are supposed to test them. So for that we require a scientific approach. That scientific approach would be provided by testing of hypothesis. Okay. Anyways, now I explain how to use MS Excel in order to calculate descriptive statistics and also test of hypothesis. Shall I?
Yes, sir.
Sir, excuse me.
Yeah,
A
please.
small query. That's all.
Please.
Sir, when doing Z test or T test, we have the information about the sampling distribution, I think.
Yeah, exactly.
But then sometimes there are population distribution and sample distribution is something different. Am I right?
Yeah, exactly.
What are the significant areas when we should consider population distribution also, rather than merely sampling distribution?
Now, as far as Z test is concerned, we always assume that population is a normally distributed.
Yes, normally.
No, let me explain. Very good doubt you have raised. What exactly normal distribution meant for it? Suppose if I want to make people understand, anybody who is studying BSc or BTech or MBA, so there is a specific approach. But non-BSc, non-BCom, anybody who is not having any much understanding about statistics, I'll explain normality in this way. So normally distributed in the sense, if you take any population, that population should contain all categories of people. Then it is called as a normally distributed one. Okay. For example, if you consider a data like -3, -2, -1, 0, 1, 2, 3. Now, if you look at this data, negative values are there, positive values are also there, right? And even 0 is also there. Then also we can say that it is normally distributed. Okay. One more example I would like to give you. Having 5 fingers in a hand is normal, right? Will you agree or not?
Yes, sir. Normal.
If you take 99% of people, 99%.
అప్పుడు అన్న గ్రావిటేషన్ కంప్లీట్ కాకపోతే మంచిగా చెట్లలో కూర్చొని గ్రావిటేషన్
Madam, please unmute yourself.
Yeah, I request somebody has to mute themselves so that it would not be disturbing the class. Now, yeah, exactly. Now, see, it is like this. Having 5 fingers in hand is normal, right? 99.99% people will have 5 fingers in hand. But there are few people who doesn't have 5 fingers in hand. We say that if they are having 6 fingers like Hrithik Roshan, we say that he's he's abnormal guy, right?
Yes.
Suppose any person having lesser than 5 fingers in hand, we say that there is some kind of disorder, right? We say that he is subnormal guy.
Yes.
So what exactly normality, in the sense that if any character is possessed by majority of people in the population, then it is called as normal.
Okay.
So generally we always assume that whenever you take a larger sample, a larger sample always follows a normal distribution. Okay. Right. For example, if you take a small sample or a particular population is not at all following a normal distribution, rather it is following a binomial distribution. For example, now elections are going on. Imagine that only 2 parties are there, BJP and Congress. Let us say BJP and Congress. Then I am distributing entire population into 2 categories only. It is a binomial distribution. It is not a normal distribution. Am I right or not?
Sir, you are right. Got it. Yeah.
So distribution in the sense how observations have the pattern. Distribution is nothing but pattern that you observe in the population.
So that is frequency distribution also.
Yeah, exactly.
But it is
exactly. When we are considering numerical data, we have to form the frequency distribution.
Okay.
Right. When we are dealing with data, generally we form the frequency distribution. It could be a discrete frequency distribution. It could be a
continuous. Yeah.
Okay. So when it is a continuous distribution, majority of the times we expect that, for example, in the continuous frequency distribution, variable is age. Okay. So age is normally distributed. We assume that age is normally distributed in the range of 0 to say 100. Age cannot be -30, -20, right?
Right. Yes.
Okay. Like that, there are so many other distributions, sir. Population is there. Population of India is exponentially distributed.
Yes.
From over the decades, we have been observing it, right? It is exponentially distributed because it is not even arithmetic progression. Exponentially, it has been increasing. So we try to distribution is nothing but the pattern that we observe in the population.
Okay.
Okay. So what we expect is, if the sample is taken from that population, we expect that the same pattern would be observed. Right? Okay. So that is the reason we always assume that the population is normally distributed. Incomes are there. Incomes are normally distributed. Because high income would be there, low income would be there. Understand?
Yes.
So people would be distributed normally. Understand? That is normally in the sense, majority of middle class people who are high, 70% of Indian people are middle class. Their incomes are, let us say, nearby 30,000 or 40,000 per month. But there are some cases whose income is more than 10 lakh per month. Right? There are some people whose income is lesser than 1,000 also. But the percentages are very less.
For example, like we are taking per capita income of country or state.
Per capita income, see, we cannot say that per capita income is not normally distributed. Per capita income depends upon so many sectors.
Okay.
So per capita, for example, in agriculture sector, from last year to this year, there is only 1.5% growth. Okay.
Yes.
And as far as manufacturing sector, there is a 10% growth.
Yes.
As far as defense sector is concerned, there is a 25% growth. And for IT sector is concerned, there is not at all a growth. Instead, there is a depression. So when we consider all these sectors together and average out, we get a national GDP, gross domestic product. What do you call GDP, right? Average GDP. So it depends upon all the sectors. Okay, sector-wise, we need to see whether it is normally distributed or not.
So wealth distribution, you are talking about wealth distribution, incomes of the people.
Yeah, wealth distribution. So wealth distribution is now, so for example, say it is a Pareto principle. What is a pattern? 20% of 80% of entire wealth is lying with 20 people, 20%.
Yes.
Right? So then this is not a normal distribution. It is a kind of 80-20 pattern.
Yes, we have a higher income with few hands.
Yeah, only few, in the hands of few people, the entire wealth is lying.
Yes.
Am I right or not? So in that case, wealth is not, normally distributed. If it is normally distributed, majority of wealth should be lying with middle class people. But it is not so.
Yes, sir.
I think you are getting my point, right?
Yes, yes.
Okay, fine. Now I'll come to the Excel sheet. I'll show the Excel sheet. Are you able to see the Excel sheet now?
Yes, sir. We are able to see the sheet. Name, gender, blood group.
Yeah. Now, to make you understand, I have taken a sample of, it is only confined to 39 members, so that I can apply a large sample test. Okay. Now, just I would like to throw some light. What exactly large sample?
I think it is 8, sir.
Greater than 30.
Greater than 30, it is considered as a large sample. If it is lesser than or equals to 30, it is considered as a small sample.
Small sample.
So for large samples, you can, for variables or attributes, you can go with the normal test or Z test. For lesser than the smaller sample is concerned, then we can go with the t-test, chi-square test. There are so many other tests are there. Okay. Now, if you look at this particular data set, every column represents a variable. We also consider it as a character, and these characters are by some qualitative characteristics are there, some quantitative characteristics. I just explain about them. Name, gender, blood group, and vaccination effect. See, all these variables are qualitative in nature. They cannot be explained by numericals. Even vaccination is also, 1 stands for vaccinated, 0 stands for not vaccinated. Am I clear? Yeah.
Yes, sir. Clear.
Please. Yeah. Now, what are the variables Variables in the sense the value which changes from one observation to another observation or one subject to another subject. So there are 39 subjects are there. So all rows represents subjects and all column represents variables. And these variables are classified into qualitative variables as well as quantitative variables. Okay, now I'll explain initially how to calculate the descriptive statistics of this particular data set. Now, descriptive statistics will be calculated for quantitative variables only, not for qualitative variables. That means that you cannot calculate mean name, mean gender, mean blood group, mean vaccination, mean effect. No. But we can calculate what is the average age, what is the average height, what is the average weight, what is the average weight of the children before a particular supplement is taken, and what is the average weight of children after supplement is taken. Now, this is a data set I have collected. My objective is, the moment I collect a data, in view of objectives only I collect the data. My research objectives are, first of all, let me understand what is the mean age of children, and what is the mean height of the children, what is the mean weight of the children, and also I would like to understand, when a supplement is given, what is the effect of supplement on the children. So before supplement is given, I have taken all those weights, and after supplement is given, after some time t, I have weighed weights of the same children. So I have collected the data. So that means that my nature of research is not only descriptive, not only explorative, but also it's an experimental kind of thing, right? I'm conducting an experiment on 39 children. What is my intention? When a supplement is, I would like to understand a supplement is effective in increasing the weight or not. Okay, that is one objective. Second, what is the effect of vaccination on these children? These are the two objectives. And along with these objectives, I would like to understand what is the mean age of children.
Objectives, sir.
Can I repeat these objectives?
Yes, sir.
Yeah, the first objective is what is the to understand the effect of supplement given to the children. A supplement food, let us say Bornvita or a Boost, Horlicks, whatever it is. What is the effect of that particular supplementary food on the weight of the children? This is one primary objective of my study. Second one is, I would like to understand whether vaccination is really affecting the children in controlling a particular disease. So for that I collected the data. So how many variables are there apart from demographic details? 1, 2, 3, 4, 5, 6, 7, 8 variables are there apart from name. So totally 9 variables are there. Now generally when you go for a research, you will have plenty number of variables. And you are supposed to go with a larger sample or a smaller sample. That's a different issue. Okay. So based on your objectives, you are supposed to administer the questionnaire for collection of data, or you can go with an interview method, or sometimes you can go with a mailed questionnaire method. And nowadays everybody using Google Forms also, right? Because everybody is having internet, so I can distribute the questionnaire through online Google form. I can distribute a Google form so that I can gather the information from every respondent. Now just imagine, yeah, please.
Sir, I just had a small clarity I need. Like we are giving food supplements, right?
Yeah.
These food supplements, they may increase the resistance of the child and may protect them from some diseases.
Correct.
It is coming in between the vaccination part.
Yes, exactly. Very nice. So that means that now there is a interaction effect of the supplement also. The supplement may increase the immunity level, or the supplement may also reduce the immunity level. We don't know.
Yes, sir. That is the doubt.
So that is the reason I have considered all these variables. So this is just an example, my dear participants. But my intention is how to run a Z test, how to run a T test on this. Okay. So initially I prepare H0. Now what is my intention? Now my intention is to understand what is the average height, weight. So first let me explain the descriptive statistics, how to calculate the descriptive statistics for every variable, right? Shall I?
Please go ahead.
Yeah.
Wonderful.
Yeah.
Wonderful.
Yeah. Now you are looking at Excel sheet. Now I have an option called data. Please click the data. The moment you click the data, you will have an option called data analysis. Okay. So generally when you open data analysis, a window would be popped up. Are you able to see this window?
Yes, sir.
Yeah, very good. Now if you look at this window, there are plenty number of statistical applications we have, or I say statistical techniques, starting with respect to alphabets, ANOVA, two-way factor, ANOVA, without replication, correlation, covariance, descriptive statistics, exponential smoothing, F-test, Fourier analysis, histogram, okay, moving average, random number generation, rank and percentile regression, sampling, t-test, okay, t-test paired two sample for means, t-test two sample assuming equal variance, t-test two sample assuming unequal variance. Okay, so like that we have z-test two sample for means also. So we have so many